This is a short presentation of new tactile control objects, which we have mounted in our KTO demonstration and development unit. As of today, we have completed the design for both rotary knobs and faders and will commence mass production in the next few weeks. The rotary knobs offer a unique design as there are no moving parts which are touching the screen surfaces, yet they offer 100% reliability and fastest response. First, I want to show you how an industrial touchscreen can read our rotary knobs and faders. As you can see, there are no dropouts, and the rotary knobs perform perfect rotating action. Also, the faders show very nice peaks and have no interruption when fading up and down. This happens with a sampling rate of the touch controller set for 100 Hz, which is quite a normal speed for a traditional industrial touchscreen surface. Now let me switch to our test and analytics program because that will show you some more information. Our test software has a page on the right side which shows the raw data as it comes in from the rotary knob, and it's fitted with a filter algorithm to show the increments the knob can generate. When rotating the rotary control knob, we convert the pulses of the touchscreen into increments, which are just limited by the sampling rate of the touch controller. With a 100 Hz sampling rate, you can produce at least 400 pulses when rotating slowly, and more than 100 pulses when rotating fast. Based on this resolution, it is very easy to generate more than 64 increments in one full rotation, which is much better than most analog operating incremental knobs can produce. In this instance, we have 101 increments generated by the knob. From a mechanical point of view, it has been the goal of our design team to develop a knob which offers even better and more constant torque than a traditional rotary knob. As you can see, there is no wobbling on the axis, and the knobs feel just perfect when you rotate them. Our design guarantees 30,000 cycles without any loss of quality, and with a constant torque through the knob's lifetime. As neither the rotary knobs or the faders touch the screen with any moving parts, there is no abrasion possible, and dust or dirt will have no effect on performance. Also, it has been very important to make sure we offer the best possible pull-up strength of the rotary knobs. So the bonding of the knob is strong enough to allow me to lift the entire TFT monitor with just one lob. But we also have to make sure the rotary knob will come off before any shearing forces could break the glass of the touchscreen. As far as the faders are concerned, those mechanical aspects are less significant, but on the other hand, we had to ensure that the fader movement feels like a traditional fader. The challenge has come in avoiding blocking any view of graphical elements surrounding the fader, so the fader must avoid taking up too much space above the touchscreen. Our unique fader design consists of two parallel triangular shaved rails which give proper view positioning and definable and constant slide resistance. So now the faders adjust 5 mm deep for best possible view to the screens, same as a high quality analog fader. Sliding the faders, we can now generate up to 100 pulses with just 65 millimeters of slider travel, which is far better than most analog faders can produce. In conclusion, we believe that our tactile objects are the best you can get on the market and give experienced software developers a perfect tool to quickly develop human-machine interfaces with haptic control elements, all without spending time and money on mechanical or electronic design. And the best news is, these components are available now. Thank you.